Hello guys, good morning. Good morning, BU. Happy Pongal, all of you. So today we have a refraction, discussion. All right. So happy Pongal. Good morning. And refraction. Where are the questions? Okay, so shall we start with the first question? So the first question is about accommodation triad, and the question is all except. So beautiful question, no? 4 options. You have 3 which is part of the triad and 1 is which is not part of the triad. Good morning, Vinod. Good morning, beta. So accommodation triad. What are the components of accommodation triad? Number 1, convergence of eyeballs. Okay, so convergence of eyeballs, both the eyeballs. Number 2, meiosis, constriction of both the pupils, meiosis. And number 3, increase in anterior curvature of lens. Okay, increase in anterior curvature of lens, because the purpose of accommodation is to bring the near point, the near vision, the near image forward onto the retina, because normally the near image is behind the retina, it is focused behind the retina. So the purpose of accommodation is to bring this near image which is behind the retina forward. So that means you want to reduce the focal length. If you have to reduce the focal length, we have to increase the diopter. Okay, so we are increasing the diopter of the lens, the dioptric value of the lens. How are we increasing the dioptric value of the lens? By increasing its curvature. Okay, increasing which curvature? Increasing its anterior curvature. Is that clear? So what are the components of the triad? Number 1, when you focus on a near object, both your eyeballs have to converge. Near object means they converge. Okay, so convergence of both the eyeballs, meiosis, and the purpose of meiosis is to increase the depth of focus. Okay, to increase the depth of focus. And number 3 is to increase the anterior curvature of lens. So these are the components of the triad. So let's see what is not a component. The contraction of zonules, option A. See, when the accommodation happens, how does the accommodation happen? Accommodation happens because of which muscle? Because of ciliary muscle, right? Now which ciliary muscle? Your circular fibers of the ciliary muscle. All right. Now the circular fibers of ciliary muscle, when they contract, the zonules will relax, because normally in a resting state they are more in a contracted state, they are in a stretched state. Okay, so when the circular muscles of the ciliary muscle contract, the zonules will relax. Okay, so that is the answer. So that is a false statement and it's not part of the triad. See, although even the relaxation of zonules happen, but that is again not a component of the triad. It does happen during accommodation, but it is not a component of the triad. Happy Pongal, Vicky. Iniya Pongal Nalvazhukkal. Ellarukkum Iniya Pongal Nalvazhukkal. Okay, Pongal la saaptacha. All right. So next one, the transposed equivalent of some prescription. Guys, it's very simple. See, transposition involves 3 steps. Okay, so I always devised it as 3 steps. So first is you have to get a new sphere. Okay, a spherical component, then the cylindrical component, and whenever you have a cylinder, you'll have an axis. Okay, because cylinder has to be placed in some axis. Okay, whatever axis. So you have a new sphere, new cylinder, and a new axis at the end of transposition. Okay, so whatever prescription they give you, you do these 3 steps to get these 3 things. Okay, so how do you get your new sphere? Use your algebraic knowledge. Simply add, taking care of the signs. So algebraic sum of whatever value they have given in the diopter sphere and diopter cylinder. So here it is a +1 sphere minus 0.5 DC means diopter cylinder. DS means diopter sphere. Okay, minus 0.5 DC at 90 degrees. Right? So +1 sphere minus 0.5 cylinder at 90. So this is our given prescription. Okay, so what is the first step? I said take care of the signs and add. So +1 sphere minus 0.5 cylinder, +1 minus 0.5, when you add them, +1 minus 0.5, when you add them, you're going to get plus 0.5. Yes or no? Agree? Give me a thumbs up if you understood this first step. +1 minus 0.5 kitna hai? What is it? It is plus 0.5. So that is our new sphere. So what is our the transpose prescription? What would be our spherical value? It would be plus 0.50. Okay, plus 0.5 plus 0.50 ds. Is it clear to everyone? You give me a thumbs up, then we'll go to step 2. Very good. But yeah, very good. Super Vicky, super BO. Now, second step, whatever cylinder they've given, okay? Whatever value, keep the value. Take the value, put it in the new prescription. Just change the sign. So here, the given sign is a minus. So they've given minus 0.5. So minus 0.5, you bring it down as plus 0.5. Don't tamper with the number. Just take the 0.5, bring it down, change the cylinder, change the sign. So given sign is minus 0.5, so now it will become plus 0.5. Yes. So now we have a plus 0.5 sphere, plus 0.5 cylinder. Now what to do with the axis? So always change the axis by 90. Either you add 90 or you subtract 90. Taki, the end result should not be 0, should not be more than 180. Yes. 0 is equal to 180. We all know this protractor. No, protractor mein 0 and 180 are same. Horizontal, this end is 0, this end is 180. So 0 is equal to 180. We don't write 0 degree. If you want to write 0, we will write 180. Okay. And the resultant axis should not exceed 180 also when we write the prescription. So you come back to this opposite angles. I think it's opposite angles. I'm not very sure about the mathematics geometry. So you come back to that. So either you add 90 or subtract 90 from the given axis, okay, so that your end result is less than 180. Let's see what is given. 90 degrees is given. So if I subtract 90, I will get 0. 0 is equal to 180. Or if I add 90 to 90, 180. So my new axis is 180 degrees. Is this clear to everyone? So what is my transposed prescription now? Plus 0.5 sphere, because plus 1 minus 0.5. So plus 0.5 sphere. Then what was given to me? Minus 0.5 cylinder. So when I did step 2, it became plus 0.5 cylinder. What was given? 90 degrees was given in my original prescription. So when I transpose 90 plus 90, 180. So my answer is plus 0.5 sphere, plus 0.5 cylinder at 180 degrees. Is that clear? So I write it as plus 0.50 ds, diopter sphere, plus 0.50 diopter cylinder, that is DC, okay, plus 0.5 DC x, that is at 180 degrees. Is this crystal clear to everyone? So now it's a mind game. I've got my answer. Now I have to look carefully. Okay, so be very, very attentive when you're reading the options so that you don't get, bogged down by what the combinations of plus, minus, and don't be careless here. So our answer is option C. Yeah, clear? Okay, next question. Which of the following lasers is used to make the flap in LASIK? See, I've told you when you're making the flap in LASIK, you can either make it manually using a microkeratome or we can use a laser. Yeah, either manually using a microkeratome or using laser. So when we are making a laser to make the flap, so what is this flap? See, cornea has 6 layers. All of you know cornea has 6 layers. So we make a flap just beneath the Bowman's layer. So in your flap, you will have epithelium and Bowman's. Okay, so when you're doing LASIK and you're lifting the flap, this flap has, you don't take it off. Okay, it's like a door. There's a hinge because you'll put it back. So this has epithelium and Bowman's layer. All right. Now, how can you make it? Either you use a blade, a microkeratome to, blade means not your shaving blade. Okay, I'm just saying. Okay, so microkeratome, so you lift it, or a laser. So remember the flap F wala laser. What is that F wala laser? F wala laser is your femtosecond laser. Okay, femtosecond laser is used to make the flap of LASIK. Is this clear? Parth, you can join the test and discussion. Okay, so you will definitely understand, or you can take one of the courses. You will definitely understand. Don't worry. Okay, so please ping me. There is this link that I've given in the description. You can use that. Alright, so let's go back to the question. Which of the following lasers is used to make the flap in LASIK? Excimer laser. No, excimer is to do the ablation itself, not for the flap. Okay, please don't get confused. When you want to do the stromal ablation in LASIK, we use the excimer laser. But to make the flap, it is femtosecond laser. Yes? So option B. Now this image, okay, so what does this image show? So this image is showing you the cornea, the lens and light rays focusing at 2 points or 2 lines are formed, 2 foci are there. So when there are 2 foci, obviously this is not a refractive error, this is an astigmatism. And when I have 2 foci or 2 focal lines, it is a regular astigmatism. So this is definitely regular astigmatism. Now when I have the 2 focal lines in front of the retina, both of them, see this is a retina and I have F1 and F2 in front of the retina. Image in front of the retina is called as always myopia. So remember, I've got a myopic astigmatism. Yes, I've got a myopic astigmatism, and when both are in front of the retina, very good path. So this is compound myopic astigmatism. When both the focal lines are in front of the retina, then it is called as compound myopic astigmatism. If on the other hand, if both of them were to focus behind the retina, then it would be compound hypermetropic astigmatism. Is that clear? So the answer to this question is compound myopic astigmatism. Now, which of the following drugs is used to prevent progression of myopia in children? A low dose atropine. Okay, low dose atropine is used to prevent the progression of myopia in children, because when we are born, all of us, we are hypermetropic. As a newborn, we are hypermetropic. Then as the eyeball grows, we become emmetropic. But for some children, the eyeball continues to grow, elongate, resulting in the image in front of the retina. Yeah. So if it stops as emmetrop, normal, then it's okay. The image will be on the retina. But when it grows, continues to grow, it will result in a myopia. No. So sometimes it becomes excessive myopia, high myopia as well. So to prevent this myopic progression, we can give low dose atropine in children. Okay, low dose atropine. Very good. Yes, very specifically it is atropine path, nothing else. Okay, only atropine is approved also. What is the image formed at the midpoint of sternum? See, this 𝐶𝐲𝐞𝐈𝐴 conoid is very important, and the midpoint of sternum is always that circle. Okay, always that circle. What circle? Circle of least confusion, or the circle of least diffusion. Okay, so at the midpoint of sternum, please remember, it is always the circle of least diffusion. All right, and this 𝐶𝐲𝐞𝐈𝐴 conoid, what does it represent? It represents the optics of astigmatism, and in particular the regular astigmatism. Is that clear? So it represents the optics of astigmatism, in particular the regular astigmatism. All right. Next question, all of the following are true regarding aphakia except. What is aphakia? Absence of lens. Yes, absence of lens. So they are asking us to find out which is not true. Option A, first and second Purkinje images are absent. Guys, please remember, these Purkinje images come from reflections from the eye surfaces. So which are the surfaces on the eye which reflect light? Your cornea and your lens. Now cornea has an anterior and posterior surface. Lens also has an anterior and a posterior surface. So totally we have 4 Purkinje images. Okay, the first 2 coming from the anterior and posterior surfaces of cornea respectively. The third and fourth coming from the anterior and posterior surfaces of lens respectively. Yes, very good BU. Yes. So in aphakia, the third and fourth Purkinje images will be absent because you do not have a lens. But look at my first option. First and second Purkinje images are absent. No way. Cornea say it's coming. So it will be present. So we already found out the answer. Okay. Do we have iridodonesis in aphakia? Yes. Whenever you have a problem in lens. See, what are the causes of iridodonesis? What is iridodonesis? Iridodonesis is tremulousness of the iris. The iris will be shaking. Okay, the iris will be shaking. So what are the causes? Number 1, aphakia. Number 2, even pseudophakia. When you have an IOL instead of the natural lens, again you will have pseudophakia. Number 3, when there is lens subluxation or dislocation. That is when you have ectopia lentis. So what are the 3 causes of iridodonesis? Number 1, aphakia. Number 2, pseudophakia. Number 3, we have ectopia lentis. Is that clear? All right. No, blunt trauma, unless you have an ectopia lentis, there is no iridodonesis beta. Blunt trauma itself is not a cause of iridodonesis. Okay. Now, next is an image. Okay. So, this image, what does it show and what is it used for? Yes. I'll come to your questions at the end. Just type in your questions. I'll come to it at the end, beta. See, this is a band girder foil which is stuck to the glass, okay, to the spectacles, so that this patient, probably this is the good eye, okay, so this is the good eye. So in front of the good eye, this has been stuck on the spectacles so that the patient will use the amblyopic eye. Yes. Oh, there's no spectacles, it's just a foil. Sorry. It can be stuck on a spectacle also, or like in this case, it can be, just placed in front of the good eye. So this is used in, this is a band girder foil which is used in management, especially of anisometropic amblyopia, So that means this is a good eye and this is the lazy amblyopic eye. So when you place this in front of the good eye, the light that goes in reduces. So the vision is blurred. So the lazy eye will be forced to work. Yeah. So this is band girder foil or band girder filter for amblyopia. Is that clear? Alright. Next question, which of the following drugs is FDA approved for treatment of presbyopia? See, for presbyopia, that is when we grow older, our accommodation mechanism fails and we're not able to read near. So that is presbyopia. It is an age-related physiological loss of accommodation, right? Resulting in recession of the puncta proxima, that is presbyopia. So for that, a drug that has been approved by the FDA is aceclidine. Okay, aceclidine, aceclidine. Okay, aceclidine. I've talked about it in another video, so I'll paste that link here. Yes, very good, BU. Very good path. All right. Next question, intracorneal ring segments, ICRS, that is your intacs or Kerarins, was first FDA approved for. See, I've told you time and again. See, you all know that it is used in keratoconus, but first approved for high myopia. Okay, so it is used in high myopia, it is used in keratoconus, it is used in pellucid marginal degeneration. First approved high myopia. Yes, very good, Vinod. Very good, Vita. Very good. Okay, let me take your questions. Most commonly எல்லாம் சொல்ல முடியாது. அது most commonly எப்படி சொல்றது? அதெல்லாம் அது சும்மா. Okay, that kind of question they will not ask you. Okay, any drugs for no, nothing causes no drug causing iridodonesis, Vinod. Happy Pongal, Strawberry. Thank you, beta. And yes, very good you had answered yesterday. I think there was a typo. Okay, in that it is a correct answer. It was a ciliary staphyloma. Anyway, I'll explain that in today's Thursday, right? Sunday images decoded session. I will explain that. Just to tell you, very good. I am sure your autocorrect would have done something. Yes, beautiful. All right. Most common question கேட்க மாட்டாங்க. ஓகே, வேற என்ன கேள்வி? No drugs. Okay, Path, I've answered your question. Yes, trembling iris. Very good, BU. All right. Yes, BU. Fourth image. Okay, about Purkinje images, your 1, 2, 3, first, second and third Purkinje images are virtual and erect. Okay, your fourth image, which is coming from the posterior surface of lens, that will be real and inverted. Okay, just imagine you're looking into a spoon. Okay, when you're looking into a spoon, light hits like this, no? So your posterior surface of lens also is like this. For the for the light, it hits like this. Every other surface is a convex surface for the lens. For the light, for the incident light. The anterior surface of cornea, the posterior surface of cornea, the anterior surface of lens, all of them are convex. Okay. Now, the posterior surface of lens is concave with respect to the incident light, just like a spoon. Have you all seen into a spoon? At least when you were kids, you used to look into a spoon or a chamcha or a ladle, no? And then you see everything is moving upside down. Your face looks upside down, and you go and ask your parents, Appa, why is everything looking upside down, upside down? If you move this way, that moves this way, because it is a real and inverted image. Yes, so fourth image, Purkinje image, is a real and inverted image. Yes? Okay, Punjida. All right, very good. I'm so happy. So today, Pongal, you got your eureka moment. So every day you should get one eureka moment. Lovely. Oh, you're most welcome, Vinod. Thank you so much for your Pongal wishes, beta. Magpanave tevella, right? Okay, there's no need to mug up. Okay, it's all full of concepts and it's very interesting. All right, guys. So today I have given, I posted a video on Instagram about your isn't rule, because some of you just don't understand what is this isn't rule. So watch that. So, so today it's just a learning post for you. Today no question. Okay, it's a learning post. Let's learn off that. All right. So what is the test for today's Telegram quiz? Yeah. What is the topic today? Okay, lids lacrimal sclera. Okay, so today evening 6 p.m. we have lid lacrimal sclera quiz, and tomorrow 11 I will see you here on Bottapongal. Okay, so we'll do the discussion tomorrow at 11. And yes, off the love. Yes, I like that. That's my best Pongal gift I've ever got. Lovely. All right, guys. Yes, lovely. God bless you all, my dear bache. Okay, so this is longer days, so you have more amount of time to study. Winter is gone, so that means the sleepiness is gone. So you have more daylight, more time to study. Prepare well. Okay, if you have any doubts, reach out to me. I'm always available. You can join the test and discussion. How to join? I've given a link, the link in the description. And you can get a free access to the test to see and decide. Okay, so you can see and decide if it's worth it, you want to join. We're not forcing you to join. If you like the quiz, if you like the discussion, if you like the questions, you feel you will benefit, then you can join us. Okay, so God bless you all, my dearies. I will see you tomorrow. Have a good day, all of you. Ciao. What is that? What is that comment? God. Chalo, bye.